Today we're going to review real numbers. Before we get into actually showing how to express those into decimals and finding the square roots of perfect squares, we're going to go over a few vocabulary words. The first vocabulary word we're going to look at is rational number. A rational number is any number that can be written as a ratio in the form of A over B, where A and B are integers and B is not 0. Okay? So any number that can be written as a ratio. Okay? So we know rational numbers could be 3/4, it could be 1, it could be any one of those numbers. Terminating decimal. A terminating decimal has a finite number of digits. And I underline finite because finite means it's going to stop. It's finite. It finishes. Think of that. Finish, finite. It's something that's done. All right? So an example here would be 0.5. Okay? The opposite of that would be the repeating decimal, which has a block of one or more digits that repeat indefinitely. So when something is indefinite, that means it doesn't stop. So an example of that would be 0.333 repeating. So you have the repeating decimal and you have the terminating decimal. And think about terminating. When someone gets terminated from their job, that means they get fired. It's no longer there. It stops. Okay? Square root is a number that can be multiplied by itself to form a product. And we know a product is the answer to a multiplication problem. So an example here would be 3 times 3 equals 9. 2 times 2 equals 4. Okay? So if we do the square root of 9, that would give us 3. We do the square root of 4, that would give us 2. Okay? Then we have what we call a principal square root, which the radical symbol here indicates the non-negative. Okay? And if you get behind, I'll pause it in just a second to give you time to get those down. Okay? Perfect square has integers as its square roots. Okay? So I gave you an example here. Square root of 4 is 2. Square root of 9 is 3. These are perfect squares. Alright? Of course there are others, but these are just 2 examples. Okay? Then we have irrational numbers. We have rational, we have irrational. Now the irrational numbers are not rational. They cannot be written in the form A over B. An example of that, the best example I could think of with that would be pi. Okay? Then we have real numbers. Real numbers consist of the sets of rational numbers and the sets of irrational numbers. That would be the whole, that's all the numbers. Real numbers are everything. The whole numbers, integers, the rational, and the irrational numbers. They're all under real numbers. Okay? All right, we're going to turn over on the inside here. And we're going to start with expressing rational numbers as decimals. So we're going to write each of these fractions as a decimal. Okay? So we know that anytime we want to change fraction to decimal, top dog in the house. This here is one of those benchmark fractions though, 2/5. But if you did not know that, we could do 2 divided by 5 here. We know that 5 cannot go into 2, so we need to add a decimal and a 0, shoot that decimal up. So how many times will 5 go into 20? That would be 4. Multiply, subtract. So my answer would be 0.4 or 0.40. Okay? The next one we have is 5/9. Okay? Same thing here. Go over here. We'll have a little bit of space. 5 divided by 9. We know that 9 cannot go into 5. We need to add a decimal and a 0. I'm going to go ahead and shoot that decimal straight up. The 9 cannot go into the 5, but it can go into the 50, and it goes into that 5 times. So 5 times 9 would give me 45. Subtract. I would get 5. I need to add a decimal. I'm going to bring it down, excuse me, a 0, bring it down. It looks like this one here is going to be a what? This is going to be a repeating. So that's going to be 0.55 repeating. Okay, so we have a terminating decimal and we have a repeating decimal. Okay, so we're going to write that here. This one's going to be terminating. And this one here is repeating. Okay. Next thing we're going to do is find the square roots of perfect squares. So we're going to find the 2 square roots of each of these numbers. So we need to think about 2 numbers that can be multiplied by itself to give me 900. Okay. Now, 30. Okay. That's one root, and it's always the opposite, 30 and negative 30. Because if I multiply negative 30 times negative 30, it's going to give me a positive 900. So my 2 roots for that is 30 and negative 30. Okay, now when you have a fraction, you're going to take both of those numbers and figure out what the square root is of that. Okay, so the square root of 9 is 3, and the square root of 16 is 4. So that's one root. So what would the other root be? It would be negative 3/4. So it's 3/4 and negative 3/4. Okay. So now we're going to classify numbers. So here we have all these numbers here, all these real numbers, and we're actually going to classify them as whole numbers, integers, rational numbers, and irrational numbers. Okay. I'm first going to start with the whole numbers. Okay. Now we know that whole numbers can be 0 and it's all the counting numbers. Okay. Positive, no negatives. Okay. So now let's look up here and let's find some whole numbers. I see one would be 0. Okay, that's a whole number, so I'm going to place that here. Because 0 is also a whole number, and if it's inside, that means it's a whole number, it's an integer, and it's a rational number, and it's also a real number. Okay, because all these here all these are considered real numbers. Okay, some more would be 1. That's a whole number. 3. That's a whole number. Okay, and I'm going to also do square root of 4, because when I do square root of 4, it's going to give me 2, which is a whole number. Okay, now we're going to integers. Now integers can be, we already have the positive numbers. Okay, so now let's do the it will be the negative numbers. Okay, the negative numbers. All right, so we have a negative 2. We have a negative 3. Okay, see any others? Negative 1. Okay, I think that'll be all our integers. Okay, now let's go to rational numbers. Okay, I see 1 off the bat would be this this 0.3 repeating. Negative 6/7. 27/4. Okay. 4.5. Okay. Now the rest of these numbers would be irrational. So we have pi, we have square root of 2, and we have square root of 17, and we have negative square root of 11. All right, so now we just classified those. Okay. Now, I'm going to put the vocabulary here. We'll do one section at a time, and we'll pause it so that you can get those. And here will be the rest of them.